Hello and welcome back to Apt for You. In this particular video, we are going to discuss the problem on tree and a very fundamental and basic problem, that is we have to find the mirror of a tree. Now, how do we find the mirror of a tree? So basically, let us understand first what is the mirror image. Now, you are given with provided with a tree, right? And you have an access to its root node. What we need to do is basically we need to find its equivalent mirror image. Suppose we have a mirror in between, and what would be its mirror image? So obviously, if you keep this structure in front of a mirror, you will find a mirror image like this, right? What has happened? Simple lateral inversion has taken place, right? So what has happened is basically you see one is the root node, one remains the root node. The left child, which was here 3, has now become the right child of this tree, right? This entire thing structure, which was on the right of 1, has now shifted to left of 1 in the mirror image. Similarly, if you consider root node 2, okay, we know that the position has got laterally inverted, it's fine, but its children's position also have got interchanged, laterally inverted, in the sense 5 was in the left, 4 was in the right, but in the mirror image they will get interchanged. 4 comes in the left, 5 comes in the right, right? So what we are observing is that basically that at every node we can observe a lateral inversion, right? That is, the left child has interchanged itself with the right child at every node. This is what we can observe. You can see at node 1 also things have got interchanged, at node 2 also things have got interchanged, right? Its left child has interchanged with its right child. So we need to code this particular problem. Now what would be the approach? So approach is quite simple. Let me just first of all write this particular problem statement, the example. So suppose I have a node 1 and node 3 here, node 2, node 5 and node 4, right? Now I need to find its mirror image. Basically, I don't have to find its mirror image, instead I have to convert this structure into mirror image, right? Remember, I just have to convert it into its mirror. Means you are not going to have any separate tree. Instead, in this tree itself, you have to convert it into its mirror image. So the idea is very simple. What is the idea? We are going to first of all, let us see what we have basically. So we are provided with the access to its root node, right? We know what is the root node of the tree. So we are provided with the address to this node. Let us declare some pointers first for convenience. So the pointers that we are going to use is basically struct node left child comma star right child comma star root, right? And we will say root is equal to node. Fine. For simplicity, for ease of understanding, I am assuming, okay, this is the node that they have passed, and this is nothing but the root node, isn't it? The root node. So I have named it as root. Star root, and root is equal to node. Fine. So this is where my root is pointing to initially, and now I'll use two pointers to point to their left child and the right child. So basically, what is left child? Left child is nothing but root left. Done. Right child is nothing but root right. So what did I get? I get two pointers, basically the left child and the right child, and you can see left child is here and right child is pointing to this. Done. Now what we are going to do, we are going to interchange these pointers. Basically interchange in the sense I am going to use swap. So I will say swap the value of left child comma right child. So we know that left child and right child both are pointers. Left child is storing the address of this node, right child is storing the address of this node. So if I interchange, then what will happen? Left child will store the address of this node and right child will store the address of this node. So what will happen? You see, if I do swapping, then I'll assume, okay, left child is now storing the address of this node, right node, right? So left child comes here, left child. Right child is storing the address of which node? The left node. Done. So this thing has taken place, fine, but you can see that there is no change in the structure of this original tree. There is no change in the structure of the original tree because 3 is still on the left, 2 is still on the right. But what we can do is now we can say roots left. This roots left should now point to the left child. So what will happen if I say root left is equal to left child and root right is equal to right child. So I'll get this structure, right? So root left equal to left child, because now after swapping this is the status of the pointers. So root left, so I have 1 here. 1's left is equal to left child, and left child is pointing to this structure, right? This node. So entire basically this structure will be coming here. So 2, 5 and 4. Root right is equal to right child. 3 comes here. Done. Now definitely you should you are using recursion. Definitely you are using recursion, you can see. So yeah, we will be using recursion now. Why? Because we have already performed swapping at this node, right? When we are considering this root node, we have already swapped its children, but there are more nodes below this root node, like node 2, node 3, again node 5, node 4. So at every node, since we have to perform swapping, so what will I do? I will do a recursive call. How? So I will say mirror is a function, and I will call the mirror root left. So basically means now perform the mirror image of this. Now find a mirror image of this structure. So if I find the mirror image of this structure, this will be my root node, this will be left child, right child, they will be interchanged, right? And again I'm saying find the mirror image of this structure. So mirror right child, root right, fine. So this is the recursive call, and you know that if we are using recursion, there should definitely be a base condition. What should be the base condition? The moment I find that okay, the left child and the right child are null, basically when I'm pointing to a null value, so I should return there without doing anything. That is why I'm writing here in the base condition, if root is equal to null, you should basically return simply, nothing else. That's it, right? So yes, you can see the working. Now root is pointing to this 2, left child is 5, right child is 4. If I interchange, then right child will come here, left child will come here. So basically now we are saying root left is equal to left child, so 2 should now point to 4 in the left. So what would happen? They will swap. So what happens? 4 comes here, 5 comes here. Done. Again you are calling a mirror on the root left. So if I do the mirror of this root left is nothing but null, and if it is null, we know it is just returning. Root right, nothing but null, returning. Again mirror image of 5, root left null, root right null. Done. So no inversion takes place here in these nodes, right? Because they are the leaf nodes. Considering again this one, the call of root right on this, so it is trying to find its mirror image left. That node is nothing but null, returns. Mirror root right is nothing but again null, so returns. So this also has completed its performing its mirror operation. So finally we have completed our entire operation, and we have the mirror image of this tree, right? So I hope you got the point and how this problem is working. In case of any doubt, please feel free to put it out in the comment section, and let us now quickly compile the code and see it's working. So let's compile the code. So yes, the code has worked fine. Now you see this is basically the in-order traversal, right? So the question had clearly mentioned that we just have to perform the mirror image, and the problem itself will do the in-order traversal. So see, we just have to complete the function mirror that takes nodes as the parameter and convert it into its mirror. Okay, and the printing will be done by the driver code only. So driver code is doing nothing but finding the in-order traversal of the mirror image. So this was the tree that I have received. My function is basically converting into its equivalent mirror image, and the function here is just printing its in-order traversal. That's it. So let us now submit the code. Considering the time complexity, so obviously time complexity is order of n because we are traversing every node. Space complexity is basically, you can see the number of recursive calls, and you can see at every level we are basically doing a recursive call, right? At every level. So yes, the problem has worked fine. So what is the space complexity? Obviously order of the height of the tree. Why? Because you can see at every next level we are doing a recursive call, right? Doing a recursive call. So basically it depends upon the depth of the tree, the height of the tree, right? So yes, we have basically satisfied the conditions that we need to satisfy order and time complexity and order height of the tree auxiliary space. So that's all from this side. I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section. Just like, share and subscribe. Thank you.